request, can you see if there is an recording option that you can see? Because from my side, I can't see any recording option.
No, start recording is disabled for me.
Yeah, so it might.
3 dots, right? You might see start recording.
So I think that it is for only enterprise version or something. For personal, I think they don't allow start record.
Okay. So next time onwards, can we use the bits one?
No, for bits one, there is a problem that we cannot create any event. And yeah. You can start.
But if you want to use bits one, what bits is one person can start a meeting and he can add other people.
But I can't.
No, if you want to use bits IDs for this meeting, then what we can do is we can one person can start a call with another person, then they can add the invite persons, or they can add the persons to the call.
Okay.
So in that case, we cannot share the link beforehand.
Yeah, we can tell them anyone wants to join, please give us their mail ID so we can call them.
Yeah, that is fine. We can do that.
Yeah.
Next time onwards, let's connect through Google Meet only. Okay, coming back to this, I think last class we went through that decision algorithm, right? So there is and we have learned some of these terminologies like target concept, instance, all those concepts, terminologies we have learned. So in the second chapter, what they are mainly dealing with the concept learning. So concept learning is inferring a Boolean value function from a training example. You have a training example and the output of that will be a Boolean function like yes or no, true or false. That kind of Boolean value result, if you want to get, that's the concept learning principle. So final output will be yes or no or true or false. Like that, you will have a decision making algorithm.
Just like in decision tree. It is similar
Correct.
to that.
It's same example we are planning to cover. But here, last class, we have learned the concept of hypothesis, all those, right? So those we will cover now. Means how to use those terminologies to make the decision. Or mainly, so we have learned, right? X is the input or attributes which we are giving to the system, to the model, and Y will be the output. And we are trying to formulate f of x. And f of x we don't know, so we will be formulating h of x. H of x is a hypothesis. And in hypothesis itself, we have two terms we learned last class. One is generic hypothesis, and the other one is specific hypothesis. Generic is, as a overall, we are telling all animals have 4 legs. And in that specific, if we take cat will also have 4 legs. So that's how the generic and specific condition we are taking. So we are bringing the same here to create a hypothesis for our model. So the same example we have seen in the other class, where let me show you. I think it is there. So we have these entries, and we are trying to see whether that person enjoys sport or not. So for that, we are taking these 6 attributes: sky, air temperature, humidity, wind, water, forecast. These 6 are the attributes which we are considering, and enjoy sport is the final output. or the Boolean value which we are arriving, yes or no. So what the hypothesis we have, right? We learned, did we learn this question mark and null yesterday? I don't know.
I didn't. I didn't attend that webinar.
Okay. So if it is a question mark, whenever we create a hypothesis, right? If it is a question mark, that means any value it will take. And if it is a null, means no value is acceptable. And if we are specifying one value, that will be the value of the attribute. So that's how we are framing a hypothesis. And one with all null is the specific hypothesis. And one with all question mark is the generic hypothesis. But that is not, when we take a case, with all null is not the correct way to tell, right? Or with all question mark is not the correct way to tell. But those are the two extremes. One is if no value is acceptable. One is any value is acceptable. So these two cases are the boundaries. But in between, we need to frame that hypothesis.
But Veena, if there is all question marks, or if there is all null, so how it fits with the hypothesis? I mean to say that if I want to create any hypothesis, we need some variables beforehand, even a single variable. Suppose you gave the example of the cat, so it has 4 legs. So there should be certain things instead of this question marks, all question marks, and all null.
Correct. So it is like, if whatever be the condition, I will go for the sport. I can tell that, right? I'm going to play something, and whatever be the condition, irrespective of any weather condition, daily I will go for sport. That will be the condition where we are putting all question mark. And whatever be the condition, I will not go for that. I don't enjoy sport. That is the other side of that condition. Whichever weather it is, I don't enjoy sport. So between these two, we need to start somewhere, right? So we are taking the extreme conditions, and from there we are trying to frame the hypothesis.
Makes sense.
So given there is one example they have given. So the sky, they have mentioned question mark, cold, high, question mark, question mark, question mark. So first is sky temperature any, and the cold and high. The air temperature is cold and humidity is high. Then we need to see in this case whether he will enjoy sport or not. So like that we are framing the condition. So the general hypothesis will be, like I mentioned, it's all question mark, and specific possible hypothesis is all null. So this is the start point of whether to decide. But we will come to a algorithm where we will consider two algorithms. One is the candidate elimination algorithm. Second is the findest algorithm. So based on that, we will arrive at a hypothesis. But before that, to get familiarized with the terminologies, these are coming in. So that's okay. The set of items over which the concept is defined is called set of instances. So all the cases, the example 1, 2, 3, all those are instances, which we denote by X. So in the current example, X is the set of all possible days, each represented by the attributes. So the column values, whichever we are considering, those are called attributes. Each row value is called instance. Each column value, whatever we consider, it is called the attribute. Based on attribute, we are arriving at the Y value. So sky, air temperature, humidity, wind, water forecast are the attributes here. And the final value which we are arriving, it is called the target concept. So that is the function we are trying to derive. That function is denoted by C. This is the generic notation. And C of X will have a value 0, 1. Either it is yes or it will be no. This is how we are trying to frame that. So C of x equals 1 if enjoy spot equals yes, and C of x equals 0 if enjoy spot equals no.
Veena, actually this x means one row or what?
Each day value, whichever we are taking, right? In this example, we have 4 days value. So this is a instance. So if you have all these parameters or any of these parameters, then that is an instance. Based on that instance, we are trying to arrive at this target concept.
Okay.
So kind of specifying the same thing. Instance will be any possible day or attributes. Hypothesis will be the one which we need to find. So hypothesis has again 2 types. One is no value accepted, or 3 types. Any value accepted, no value accepted, or a specific value. And the final target concept will be 0 and 1. And training example is the positive. Means when we have both positive and negative example cases in that sample data. So there are 3 cases which will say enjoy spot is yes, and 1 case which will say no. So those are the training examples that we are denoting by D. We have positive and negative example in the target function. And our aim is to determine a hypothesis. So how to arrive at the hypothesis? So we have learned inductive hypothesis last time, right? So we have this generic and specific concept, and from a specific to generic, we are going. I need to revisit that. Okay, any hypothesis found to be approximate the target function well over a sufficiently large training example. So from that training example, we are arriving at that hypothesis. That's how we are using the inductive learning. Okay, before going into the algorithm, there are three things we need to learn.
So,
one is, okay.
Veena, so in the decision tree, we take certain situations or we take training sets and we generalized it into a function. Okay. So this can be an example of inductive learning.
That's correct.
Okay.
That's correct. So the whatever supervised learning which we are doing, that is always inductive learning.
Okay.
So in this case, right, there might be question. I haven't seen any question from this in the sample question paper, but in general, right, there can be question. You will be given this sample data, and they will ask how many instances are there, how many syntactically distinct hypotheses we can frame, and how many semantically distinct hypotheses we can frame. So when we say distinct instances, we learned any possible day is defined as instance, but distinct instance, how we need to think about multiple possible options, right? So here, for example, in sky we have sunny and rainy. Air temperature we have warm, cold. Humidity we have normal, high. Wind, strong. Water we have warm, cool. Forecast we have same, change.
So it is similar to the sample space.
Can you come again?
I'm saying that this distinct and this what you said.
These values. Okay, here they have given these values, right? Sunny, cloudy. These all are instances. Correct. That's correct. So we can frame a instance with sunny and all the other things, right? So for sunny, it can be warm and cold, it can be normal and high, it can be strong, weak, like that, different possibility. Like, think of the probability. When the sky is sunny, we can have so many possible options.
Mm.
So all such possible option can come as an instance.
Mm.
So it will be, means one attribute will have 3 values. Each value can create, means the first value is 3, second is 2. Total 3 into 2 combination we can create.
Mm.
Saying, so the when they ask for the total number of instances, right, we need to consider all these, all the possible values. First case it is 3, second case 2, third case 2. Wind strong and weak, they might be giving this. In the sample data, I am not seeing this, but they might give this value, and based on that, we need to calculate. So all the possible values we will be given. So it is 3 into 2 into 2 into 2 into 2 into 2. That many combination we can create as an instance.
Mm.
Similar to probability. So the first case has 3 options, second case has 2 options. Total combination we can make is 6.
Mm.
So similar way, we can put sunny warm, sunny cold, cloudy warm, cloudy cold, rainy warm, rainy cold. So total 6 option we can take. Similarly, if we have all these parameters, we can take multiply all these values, and that will give you the total number of instances.
Mm.
Which is 3 into 2 into 2 into all those 2's, which will become 96 distinct instances.
Mm.
Now, how many hypotheses we can take? So consider the same thing. What we are telling is, we have 3 possible values for the sky, 2 for air temperature, 2 for humidity, like that it will go, right? But when it comes to syntactically distinct hypothesis, we have 2 more values we need to consider. One is question mark and the other one is null. So this 3 will become 5, 2 will become 4. So how many possible values are there? In that we have to add this 2 more for all the cases. That will be the syntactically distinct hypothesis. So when we say null, no value is accepted. When we say question mark, any value is accepted. That is possible for all these cases, right? So syntactically, we can have these many hypotheses created. Got confused?
No, no, no. It is just including all the general and the specific case. That's why it is. Yeah. And in the first, it is just only the options that we do have.
Correct. Only the possible values we are taking for instance, but when we create the hypothesis, right? I'm going back and forth, sorry. We have this option also. We can put, there was an example but question mark, right? Yeah, we can put like this. Either we can put question mark or we can put null also. So those 2 cases also we'll consider when we create a hypothesis. That is the syntactically distinct hypothesis count. And the third one is semantically distinct. So semantically distinct is, once we frame the hypothesis, you will understand. But in this case, right, if you take the negative example, this case, if you take the negative example, this rainy is coming only for negative. So all sunny is yes, rainy is negative. So we are eliminating this case. Similarly, all cases are warm for air temperature. When cold, it is no. So the completely negative case we are eliminating. So this is a negative case, this is a negative case, these 2 we are eliminating. Take this case high, High is there in yes and high is there in no, so we are not eliminating this. We will keep this one. Similarly, strong is there for all, we will not eliminate. Warm is there for yes and no, we will not eliminate. Change is there for yes and no, so we will not eliminate. These two we will eliminate. So in here the number of possibilities we are reducing.
Can you, Veena, repeat this again?
To find the semantically, what was that term?
Semantically distinct hypothesis.
Semantically distinct hypothesis, sorry. Semantically distinct hypothesis. We have the sunny and rainy. So when you take sunny, it is all yes. But when you take rainy, it has only value no.
Yes.
So that is a negative scenario. We are just claiming this as a negative scenario. Whenever it is rainy, we will not enjoy sports. Similarly, it is warm for all yes, cold for no. So whenever the climate is cold, we will not enjoy sport. But when you take the humidity high, it has yes and no condition. So we cannot eliminate this.
Oh, yes. Okay.
Similarly, strong has yes and no condition, so we cannot eliminate. Warm has yes and no condition, we cannot. Change also has yes and no condition. So this we will still consider, but rainy and cold we are eliminating because those are pure negative conditions.
Similar to that which we do in decision trees, isn't it?
That's correct.
Here, there is one more question, Veena, that when we are finding out this synthetically distinct hypothesis, so we are not creating the whole sample space. That what can be all values of these combinations, isn't it? It is just we are considering value for, we are actually taking out the permutations. What will be the combination of that? It is
correct. That's correct.
Yeah.
This is actually before creating the hypothesis, right? It's just telling these are the possible combination of hypothesis you can create.
Got it. Yes.
So when actually this that complete column, right? That sky, that can be eliminated. No, it is completely same with some.
Can you come again?
Yeah. Can you just show the above rows?
Okay.
Yeah, this one. Yeah. So here that sunny means yes and rainy means no. So we can eliminate the whole sky and air term, right?
No, sky and air we are okay that way.
Yeah, because
No, but we are fixing it. These 6 parameters we are considering. So if we eliminate, right, how we will, means when we eliminate it is any value, right? But if it is rainy, we are not going.
So when you say eliminate rainy and cold, are you indicating eliminating the entire row?
No. This is only for that. There might be a question coming in to calculate the number of instance, number of semantically distinct instance, number of syntactically distinct hypothesis. So to count that, we need to take it. So only for this calculation, we are not completely eliminating it. Only for this calculation, we are taking it out.
Okay. Yeah. Got it.
Okay. Yeah.
This is that sample data. So when you have this value, right, our first instance x1 we can consider it as, so this is how they represent that instance. Any value of x will be x1, x2, x3 like that, and x1 is represented like sunny, warm, high, strong, cool, same. And based on this, they are creating the hypothesis. So we can create any hypothesis, right? Like sunny and strong can have value, sunny and rust everything any value, sunny and cool. So like that we can create any number of hypotheses. So here we are trying to use one algorithm. How we are doing is we are initializing H to the most specific hypothesis. Which is the most specific hypothesis?
All null values are.
All null. So that case we will be taking for each positive training instance X, for each attribute AA in H, if the constraint AA is satisfied by X. So how we are doing is, first we will form the specific hypothesis, that is all null. Then we are taking the value of X. X is X1, X2, X3, X4. We have multiple days, right? So each day, if it has a positive value, that means in choice for TCS, we will consider that for the hypothesis. If it is no, in mathematics, we have learned this null hypothesis and alternate hypothesis, right? When I think it is somewhat similar to that concept. You are framing a null hypothesis and then you are proving it, creating the alternate hypothesis out of it. So here also we are creating that null hypothesis. From that null hypothesis, we will compare each value, each attribute with the previous instance. And if it is matching, we will not do anything. If it is not matching, then we will replace that value with the other one. We will see how we are doing it. So okay. So this H, whatever we mentioned, we have taken all null values. Then our first case is sunny, warm, normal, strong, warm, same. Let me see. I can bring that also. Oh. So the first case, we are defining everything as null. Hypothesis will be 6 nulls. For time being, I will just put 0. Then we are comparing this with the previous value. Here we have sunny, warm, normal, strong. So everything, this is not matching, right? So we will take the same value. Each attribute we are comparing, null is not same as sunny, so we will take sunny. So this is the first hypothesis we are framing. Normal, strong, warm. See. Then next line we are comparing. So sunny we compare with the second line. It is sunny only. Warm we compared with warm. It is warm. Now normal compared with high. It is not same, right? So what value we can put it here? It has both value of normal and high. So we have only one value to replace. It will be replaced with question mark.
Okay.
Similarly, strong is strong. Second line warm is warm. It will continue. Same is same. So this is the second hypothesis. First hypothesis is this one. From null we started, then we put this one, normal. Then we compared the next value, we created this question mark. Then third value we took, it is a negative condition, we are ignoring it. Fourth value, we are taking sunny is sunny only. Warm is warm, question mark will remain the same. Strong is strong. Again warm is cool, here it is cool. So we have to replace it with question mark. It is taking both value, right? So any value indicates question mark. Same way, same, it is changed. So here also we will put question mark. So, hypothesis we are arriving. From this training example, we need to convert it into hypothesis, right? So this is the hypothesis we will be framing. So let's look into this. So here we are framing the null. Then we took the first value and framed the hypothesis. Then took the second value. Normal is different than high, so we put question mark. Then we validated the third final case, and this is the final hypothesis, final generalized hypothesis we are taking. So we will enjoy sport when climate is when sky is sunny, air temperature is warm, and wind is strong. This wind, right? Third one. Wind is strong. So these three weather, we have this value, and this is the, based on this, for the next criteria, right? Whenever a new criteria comes in, if it satisfies these three, we will put it as a yes. We don't have to evaluate at all. We are telling these three criteria are satisfied, and the other three, any value, it will be yes. That is how we are creating a model. Any questions till now?
So this is the example of inductive learning only.
We have created that final generalized hypothesis.
Generalized.
So whenever we create a hypothesis, right, we have two areas. One is totally specific and totally generic. But we want to bring something which is more related to our sample data. That's how, based on our training sample, we are creating this hypothesis. This will be the final model we will be creating, which will validate if the weather is these three conditions. If the air temperature is warm, sky is sunny, and wind is strong. If such data comes in, it can directly put it as yes.
So for question mark, whatever will the value, it will consider yes only in this case.
That's correct. If these three criteria match, it will consider yes. I will send you a couple more examples. I'll just share you this link. This is also, So it covers the same thing. The general hypothesis, specific hypothesis, how whatever algorithm we mentioned, right? This is a pictorial representation of that.
Mm.
And there is one example also here how we are calculating it.
Mm.
And this Python code also is there. So it will validate whether it is a final hypothesis it will give.
Mm.
So just go through it.
So Veena, this is example of a classifier, isn't it?
This is example of a classification, correct?
Mm. So and okay, fine. So you in last session that we had. So in that you told us about the descendant gradient, so descent gradient, whatever, isn't it?
Gradient descent, did I take? No, right?
No, in PPT there was something that descent
Inductive and
gradient.
deductive.
Huh?
Inductive and deductive.
No, there was a algorithm, na, gradient related descendant gradient.
That was in the class, right? I think last class the ma'am took.
Okay, fine. So I was thinking if you can in next session if you can take example of that also. It
Yeah,
is with regression.
Yes.
Mm.
We'll do that.
Okay.
We can have tomorrow also. We can have one session.
Mm.
Friday I may not be available, but tomorrow we can take.
Okay, fine. I will share link for that.
Okay. There is one more algorithm on this candidate elimination algorithm that will compare from both generic and specific. It will consider both cases and validate against both and finally arrive at. Next class we can start with it and then move to the gradient descent.
Okay, fine.
And there is the second session what we are taking, right? In the class it is related to mathematics. It's just a refresher. We don't need it, right? Or do we need to cover it? It's more related to probability, metrics and all.
So if someone in our group wants to take it, then it's okay, isn't it? Manoj and G, do you have any thoughts on whosoever in the call?
Yeah, if she can take it, it's great. If Veena can take, no, then
Okay.
take much time or what do you think?
No, it is mainly a refresher kind of whatever we have learned till now, right? Only the probabilities coming extra. They are covering the different axioms of probability and all. But other than that, most of it are same whatever we learned in the Sem1. And we can quickly go through those slides. That can be done.
Yeah, better. Yeah, that would be a good.
That is.
So when after this question mark thing, then how is the algorithm going to work? How is going to predict with the question mark and all? Just curious about
No, here, right, in the supervised learning algorithm, we are creating that function. Means this is little internal, not from the actual algorithm perspective. What we have learned is we have a x value. X is the input which we are giving, and f of y is the output we are getting, and f of x is the function which we need to use. So how to get that function? For that, we are framing this hypothesis.
where are you going to use this HFX?
This will be means this as such this finders algorithm we will not use anywhere, but any algorithm we use it is doing the same. any other algorithm which we are using for supervised learning, internally it frames a hypothesis. How it frames that hypothesis will differ.
But if we are using this process, then definitely it is doing the same, isn't it? If you're using
kind of a manual process, right? Each entry we are validating and then arriving at a conclusion.
This is a manual process. We don't automate it. I mean that we don't do code on it.
Automation also, if let me go back to that Python code.
I think that through training data, it can make hypothesis on this. What is the machine learning?
Correct. It will just here if you see, it is taking that train data and it is validating for each case. So if it satisfies that ACE condition, then it will create that specific. It will make a change to that hypothesis. So it's kind of iterating to them. Anyway, means most of the examples, most of the algorithms will do the same thing. It will take the training data and create a function out of it.
Yes.
For the exams, we had to write some algorithms or some codes or something.
No, one question I saw is they are asking, means they will give the sample data and the possible values, and they are asking these three questions: the total instance, number of hypotheses, semantic and I always forgot that name, syntactical hypothesis, and to frame the hypothesis. So to frame that hypothesis, we need to use this algorithm and frame it. There was an example. Let's see. Okay. I'll give you this link also, but not this one. Actually, there was one more example. Let me find it out. It has actually some good diagram. If there is nothing, we can close the course for today.
Yes.
Yeah.
So, Veena, what is your elective subject? Sorry, I should.
It is SDA.
SDA. Okay, fine. That will be helpful to Manoj.
I'm in DA.
DVA. Okay. It is and then for everyone.
In DVA, are we taking Tableau or Power BI?
Tablet.
They are starting with the Tableau.
Okay. In case if you need any help in that, right? I can. I'm not a pro there, but I have some knowledge.
We need urgent help in this ACI. Very bad confusion in ACI.
Easy.
Madam.
But actually, we have some. There are a couple of people who are working on the data science area, right? They are not able to help.
Yeah, I think this Rao and even Pratiksha is SCA. See, many people are in the SCA who are really top. Veena is here, I think.
So Manoj, can we just ask in group if they can take this session in ACI if they are working with this same field and take that will be.
I think there is some sessions going on also. I'm not sure because I am not related to SCA, so I didn't follow. So but you can groups. So there is some groups also for ACI. You didn't join that?
Okay, fine. I will do. Yeah.
I think even Nagesh is there and Rao is there, and Nagesh was saying that somebody was taking the discussion also. I'm not sure.
Hmm. So you can forward me the Rao's number. I can ping him and ask if the session is going on.
Yeah, even you can ask in the meet too, but ask him the. Thanks a lot, Veena. It's a very nice.
Thanks, Veena.
Yeah, been a very helpful session. Thank you so much.
Bye. Good night, everyone.
Good night. Thank you. Thank you.